Hey everyone, it's Krista. I'm back, and okay, looks like we have microphone dots. We're on day 4 or whatever of the flange wires or fuel pump wires, and here we are. We just showed up on my phone. Okay, give ourselves a like. Oh, don't forget to like, subscribe, and hit the notification bell if you want to come say hi while I'm live. I definitely invite you to join me and keep me company at work. So here's our setup. We have the pressure vessel, and I think it's all 3/8 aluminum. I bought a bunch of at Industrial Metal Supply in San Diego, and it was just always useful to have a bunch laying around. Um, so this hose just goes to shop air, so like 100 whatever psi. I've got a regulator, a common thing set up. Actually, this is from an air compressor we had at some point. It's set for like 10 psi, and then just a quarter in PT. It's not a nipple; it's got the hex in it, but whatever, male to a blow tip. And then it has 1/8 in PT output threads, which I run 1/8 to quarter to a T. And then down this way goes quarter in PT to the coupler, and then quarter in PT to another T for a blow tip pointing out, which is a vent, and then our pressure gauge for the test. So kind of all simple piece together stuff. Of course, obviously quarter in PT tapped hole on the side, and an angle fitting. And I have 2 crush washers, probably become the tap deep enough. Um, and I have it set for 10 psi. That's like kind of all we need. Like all we need for this, honestly. So these are the wires. We just pulled them off the pipe. Nothing special. Some of them did actually still leak, like this one. The epoxy. We didn't lose much. Maybe. I don't know. I mean, the solder joint still supported. That's what matters. And we cut off the, oh gosh, that was a mistake. The zip tie holding our little 3/8 block. Of course, things go. I didn't do that. I tested all those wires. Not one did that. And then there's all this weird technology in my world. So this is my grease. I just keep grease on angle. And so I found this originally was a bracket I had bolted to a computer, and it held a fan. And then it was laying there. Who knows why. But then I put grease on it to use as a temporary source. And then I was like, oh, wow, that's really handy. So then ever since then, this has had grease. So right now it has clear, I don't know what kind of grease, some industrial crap. Wow, I didn't even know where it went. Whatever. So it just has some clear grease. Oh, there it is. Multi-purpose synthetic, nothing much. I use it as clear because it doesn't show up on customers' parts and it won't wipe off dirty. I just give it on the body and O-ring. I also apply it a little bit to the O-rings when I'm fitting them to these pieces because they're so dry, and I add it to the hole. So the hole here simulates the bottom of a motorcycle tank. It's precisely the same diameter. I mean, as close as you can get with normal measuring instruments. Like, it's within a thousandth inch of the hole in the bottom of the fuel flange, and its depth is at least that. We do not have a snap ring on the other side, so I use a toggle clamp to hold it, and I give it 10 psi. There you go. Um, so, as usual, I'm kind of a weirdo about things. I like to have a little test spot that just tells me I'm testing, kind of. So it's just, it leaks in that corner. It's always leaked. If when I see that's bubbling, I know the test is going to work. I take the ends, I dunk them into water. There's hardly any soap in this. I use the brush, the acid brush, to wipe off all of the bubbles. I don't want any bubbles down here. There's one that's really sticking. So if I make all the bubbles go away, then I know that any bubbles that are there are caused by a leak. And that white one just doesn't want to go away. All right, that's good enough. And then I take the brush and I add a great big puddle over the connector here, or at the bottom of the plug. And it'll try to fool you, and it'll have one bubble come up maybe around the conductor, and that's just the water going down along the wire. So I keep building it up to make a bigger mound. There's no bubbles, and then I take the water and I spill it around the whole thing to fill up the space above the O-ring to make sure we don't have any leaks there. That's never leaked. And we have our Millie. Hi, Ashley. And so we're good. No leaks there. I dry off that. I dry off this. I dry off a little. I leave my little test corner. I bleed off a little bit of air and loud noise. There we go. Add this to the box of tested wires. So this one, it leaked through kind of interestingly as well. That's kind of fun. So like I had all of these with a little bit of a mound on the top. So yeah, I mean, it's okay. Some leak through. No worries. We're going to cut off the brick. Let's see, a little bit more of a picture. We have our brick, put it in the bag. We reuse those for the next test. And even if I say I'm going to quit making these, I'll keep all of my test rigs and gear and stuff together. Some grease. I'll just put them in a box and write on the box what it is, because you never say never. The best chance for me not have to test more again is to not throw away the test rig. So you can't quite tell, but this does lift up against the toggle clamp. Make sure we get bubbles off. Okay. And if you can, I usually like to slide the sleeve up now. Use the wires to conduct the water down to the plug. And so if there was a leak down here, it would be active like that thing on the end. And there's nothing happening there. And pull them back down, double check here. Nothing going on. And those are good. Since we have started using this technique with the rubber connector seals, we have not had any leaks at the plug. However, we're still going to test that because the minute I stop testing that is when we're going to have leaks. Oh, we have some frayed ends. Let's take care of those real quick. Finger's still a little greasy. Yeah, okay, that works. You definitely have to re-lube the hole at least like every third time. Or then you need to start prying out the thing. And it's great. I could hear the little bubbles complaining. No one's here, so it's okay if I make mistakes. No one will notice. All right. So they're nice and wet and no bubbles. Make sure I get those wires wet. Fill the land. Okay, there's no leaks. If the wires hadn't been soldered in the middle, the leak you would get at the end is like blowing through a straw. Especially at 10 psi, it just is a continuous stream of bubbles. It's very obvious, very big leak. One more, and then I did have one test bad, so I thought I would save that to show you. Now, one thing about when you see me working on production is I'm very organized with my process. Here's my little trash box. Here's my box of good wires. Like I try to make a consistent routine just to make sure we don't skip steps and I don't ever stop something mid-test. Or if I do and I come back, I start that test over. So only the parts in that bin are considered passing. If it's not in that bin, they're not passing yet. And that kind of procedural stuff makes a huge difference in quality. Additionally, this whole time I'm inspecting the parts to make sure nothing's wrong. Like, is anything weird? Oh, that looks weird. They just look closer or whatever. This isn't maybe necessarily a product where you do that, but anytime you handle a product, you critique it for anything going wrong. No bubbles. And it's just, you have to watch, like, these stupid bubbles will try to show up and fake you out, but then you break them, and then if they don't come back, it's not a leak. Check back down here, we're good. So we did 19 wires on this batch, and that's 4 solder joints each. So that would be 80 minus 4 is 76 solder joints, and 75 were solid and successful. My normal procedure has been when a part is bad, I take this O-ring off to signify it's bad, but I'm going to keep this one as a control. So I wrote on it black wire bad or black wire leaks. And then it's kind of rare you get to actually see one of these things leak. So I thought it'd be a great chance to show. Let's see, can I get you in here better? So the bubbles you see are coming from the black connector. How could I get you even closer? Why don't we do that? We'll play with your location. Can I just lift this up to you? Oh, I can see that on the screen with my horrible eyesight, so that's pretty good. Typically, when I've had leaks on other people's, when other people tried to make it, it could be slower than this, but they always manifest the same way in that a bubble will start growing, obviously, and it will release with a tempo. Um, I've never had one escape notice because you see how the bubbles they stay for a while. Something's happening. You're gonna notice. Actually, I didn't even notice this one was leaking because I was kind of rushing through, brushing off the bubbles and getting things done. And then I saw something move and I looked, and I was like, oh, great, it's leaking. Which actually I was kind of like, oh, great, because then I had something to show you. All right, so we'll put him completely far away and set this aside. And we'll get ready for the next phase. Oh, I kind of made my whole setup a little angry here. There we go. Maybe, I don't know. All right. Won't be long. I'm just kind of putting away the things that don't belong. Nothing much to the box. Nothing much to this. I guess the only real magic was that, I built the box using a mill and I had a quarter NPT tap. So let's dry our workstation. Throw away our trash. Put our trash box somewhere else. And then we're going to dry our workstation again because we're going to be playing with electronics. All right. So the box is going to be good products. And we'll get out our test rig. All right, so underneath the display is the Express IF ESP32 chip in the center of that little board. I don't even know like people would have a default layout for it, but it's sort of arranged in a similar to Arduino Nano. I don't know. So I use some of the I/O pins, and I just simply um, push out ones, and I look for ones and zeros. Nothing too magic, really. I have some pull-up resistors or pull-down, not sure which, and some solder joints. And I'm just routing things to the pins. And then for external connections, I've got this sensor wire connector and then these terminal blocks. And so when there's no connection, it just says a dash and an X. When it's connected, it's solid all the way across. And if you do things to screw it up or short it, something will break in the middle. The only time you get 5 solid lines is when it's a good product. And then I have, for the testing itself, we put the bare ends into this, which could be you hold them in place or they're spring loaded in case you want them to stick in there. And then that's for the external connections outside the tank. We simulate the fuel pump and level sensor with connectors. And notice both of these use wires strikingly similar to the product itself. And then this is kind of fun. It's got a little spring dealio and it holds the sleeve. Now once it's in, it lets you know by making the bottom line solid, but it's also now checking against the red and the black. I don't know if it does a problem. Can we show a problem? No, I mean, I know that I've tested every way this could be bad. I mean, I don't carefully programmatically look for every possible bad condition. Okay, so let's make you a little bit easier to see what's happening, maybe. All right. So on the previous steps I was showing, I'd been doing the same test for like 13 or so times, so I had everything going perfect. All right, so I do red, black, white, blue. And all the lines are solid. All right, so I guess I'll shove them in to the spring-loaded thing and see if I can show you. Now, I actually intended it to be spring-loaded so that, the quote-unquote, the operator could make it spring-loaded. Then it turned out that the spring tower was just as useful. Oh, it's saying we have a problem. Oh, yeah, so I swapped red and black. Sure, yeah, there was a problem. See, yeah, like everything's fine until you turn on the camera and then it all goes bad. All right, so red, black, white, red came undone, and blue. Let's put red back in. All right, and so there's the indication when we have good wires. Let's see if we can get this up in your face. All right, so it's just a bunch of lines in a row, nothing special. Is this the reset? Yeah, that's the reset. I programmed it to, well, did we kill it? There we go. F-wires tester, blah, 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 whatever. Um, yeah, I guess having 2 of the pins shorted kind of grumped it out. I don't know. But the whole point of this was to make it easy to do and relatively repeatable and quick, because what I was doing was holding an ohm meter and a pin, checking every color and the thing, and doing that for each pin, and it just, woo, wow, that was pretty miserable. The spring is actually 2 different springs from a laser printer. I took apart, that one came from a brother, and then I save everything from them, and then I pick or recycle if those are available. We're in the South, we don't exactly have recycling. So I hold all the things down and I check for 5 lines. We're good. I have actually had once or twice where um, something went wrong electrically and I had to redo, or and actually it failed. I just failed the part, so I threw it out. Um, then those ends become really annoying, so I just find a way to tie them up. So nothing too terribly special. I also made this, I couldn't quite get the top of a fuel pump, so I just used the bottom 2 tabs of a connector. It won't let me put this in upside down. Plus, the wire color is red, black. Normally I would do red, black, blue, white, except for I didn't really notice when I put this together and then I never changed it back, so I just left it. When you're playing with the hobbyist embedded controllers, you have to watch out for things like you can do something to short these and it resets the thing because basically you overload its 3.3 volt power. It runs off a micro USB, so nothing magic there. Trying to think what else. These little red boards are from that Jungle website. They're super cheap and handy. They actually have pretty amazing contacts on them because, I mean, I'm not always the most conscientious solderer-s. And yeah, like they suffer some abuse. If I was doing this for normal operation, I'd probably build a little console and have this mounted so that you couldn't mess with it. And I don't know, like it would be in a box. How's that saying go? It's a temporary fix until it doesn't work. Well, that's how this has been. This connector is keyed one way, so I don't even really pay attention. It either goes in or it doesn't. And still nobody here, so I can still do whatever. No one will notice. Anyhow, that's kind of that. Um, I believe in 100% testing because if I sell a customer a bad part, maybe not just the customer is one whose time and money is wasted, but also a shop. And so my very conscientious um, detail, attention to detail has built a great reputation. Plus, like, like I really care about it not leaking. When these things, whenever we'd have a change in their something is, I would be so stressed. And you get that call and someone's like, yeah, my bike flooded my garage. And it's like I get hit in the gut. And like one time I literally just went and puked. Like, I take it way too seriously when folks have problems with products. So I really kind of go nuts with the testing. I think of the best possible test that's, well, reasonable, um, to make sure we don't waste people's time and money, especially when like some stuff we would buy from China. Like the initial design of these nobody really knew what they were doing, me or them, and only, I don't know, 5-ish% were good out of box. And so it took a long time to figure out how to test them. Yeah, let's not talk about that too much more. But I mean, like, people know I mean better than anyone. Like, I really mean well, and all I really want are people to enjoy their bikes and ride. I never want to be the source of someone's problem, and we've certainly been the solution to lots of people's problems. And I'm very appreciative of that. You know, folks trust me with their happiness. So I reckon I'll just stop this. I mean, I got like 5 or 6 more. I'm not sure how much else there is to talk about with this. I mean, everything I do, especially when I have to build something for another person to use, like if I'm the engineer, I'm very conscientious of the operator. And usually I am the operator, so that's a good motivation. But I always try to think of how ways these could be not used correctly. And I did pretty good with this on the first design. There weren't any immediate issues I could tell were completely off. So that was good. Sometimes, I mean, it's easy when you design something and you build it that you know what its intent is, you know how and why each part of it works. And an operator comes in, maybe they don't know how it's supposed to work and why, and or if they say the words, they don't understand the depth of the concepts. So it's very important that anything you make for other people to use, that you have the users demonstrate how they're going to use it for your design folks. And then you have to have your engineers and designers have to have the freedom to go back and make improvements and changes. Lots of times companies don't do that, and they just say, oh, wow, that's great, it works. And then, like, I quit a company because I got sent across the world to install something because I could make it turn on 3 times in a row. And that's not how you do things. I was the only one in our company who could make one of our products turn on 3 times in a row. So they're like, "Yeah, you're going to Korea." I was like, "Oh gosh, guess I'm getting a passport." That was Y2K sometime. And part of how, I mean, like, it all comes back to the military. I was in the Army. I enlisted for a few minutes in the Army Reserve. So we had some great training. I got to see lots of training, and folks might try to say stuff is dumbed down, but you kind of need that when maybe stuff is blowing up around you or you're getting yelled at. You don't always get to have a calm work environment. So I definitely understand making products as dumb as possible. Like, how could this be misused? What goes wrong? Like, what if your operators are having a horrible day? What if they're having to work doubles, or they're working too many hours, they're not getting enough breaks, or they're mad at um, their life or their manager? Is the engineer making a product for them to use? I need to make it as easy and safe as possible. Well, geez, I just kept BSing. We got 3 more to do. Mazel. Kind of what I wanted to do for these ends was get something I could shove them in that could hold them. And it just was too hard to come up with that. And then once I've realized you could use the spring towers and just sort of jam them in, and then you look, you got 5. I mean, I could probably have it ding a bell or something if I wanted. When all 5 are good, it goes ding. Then it leaves it good until one of them are unconnected, and then it redings. This doesn't know the concept of if a test is beginning or ending. It's simply stating the conditions of the wires it's seeing, and it's continuously monitoring them. So the human concept of performing a test, it doesn't care. It's simply going around many, many, many times a second, checking each of the wires. So by the time you go and look over at, do I have all 5 wires? It's probably gone through several hundred checks by then. Just from this moment to there, several hundred tests in its mind have passed. So if we added the bell, it would be like a state machine where you would hold that state of tested. You ding, you tested good. I don't even know if I would bother telling it to relax. This is all it does. It just sits there. It doesn't care. It doesn't know. So that's that test. Everything you see here, except for, well, obviously my wires themselves and these connectors, everything else here came from the Jungle website. If you wanted to play with an ESP32, this is, I think they call this ESP32 OLED Wi-Fi kit. OLED is the display. It has a whole bunch of pixels in it. I left its protector on. Um, I've had pretty amazing luck with ESP32 products. Trying to think. There's another thing called the M5 stack. I don't know for certain if it uses the ESP CPU as their infrastructure or not. And then there's also something called the Wii terminal. That thing's pretty awesome too, because those come with a case and have buttons, so they do that for you. Anyway, thanks so much, and I hope you enjoyed the video, and we will see you next time.